Okay, now someone will ask, why power electronics? Why do we have to even include it in our industries or some other part of applications? Now let's look at a simple circuit. Let's analyze a simple circuit. If I have a source, let's say a DC source that is controlling a simple load. So let's say a lamp. Now, if this lamp is rated as maybe 8 volts, then we have this source to be maybe 20 volts. Let's see. If there is a switch here and somebody switches this thing on, finally we will see that it will not help this lamp. The lamp may get fused or we can damage it eventually. So we want to protect the amount of current that will reach this lamp, because we know that when we just power it this way, the whole voltage will be across this lamp. So something has to be done to this so that we can protect the lamp from damage from this high voltage. So the question will be asked, how do we prevent this, or how do we prevent the inflow of this large voltage to the lamp? So the best answer to this is to bring in another component that will be able to limit the voltage for us. Because if I'm able to put a resistor here, this resistor will be able to drop part of the voltage coming here, because it is in a series circuit, and we know that in series circuit this voltage will be shared among these loads, and it will even be shared according to the amount of resistance that each of these components is exhibiting. So what we do is that we can now check the amount that is coming here. Now, if I have something of this nature, it tells us that this 8 volts will be taken by only the lamp, or the lamp will only be feeding from only 8 volts. Then what is the rest of the voltage? How much is now being taken by this resistor? And at the end of the day, when we do our deductions, we will see that maybe 12 volts will be taken across this. So 12 volts. Then another important question comes out. If I'm having 8 volts for a lamp, what is this resistor for? The resistor is just there. The purpose of this resistor is just to limit the voltage, but it will not provide anything useful. So definitely, this voltage that is taken across here is just a loss. We treat it as a loss. It's only this one that we are utilizing. So from our scientific point of view or technological point of view, definitely it tells us that our input, if our input is this 20, then definitely the output too is just 8 volts. So our energy input, so energy input with reference to these voltages is maybe 20. Then our energy output will be maybe 8. So per simple scientific calculation, we can see that the efficiency of this whole design will be given by the output by the input. So we have our 8 divided by 20. So with this, we can do our cancellation, and we see that this our 8 divided by 20 is going to give us something like 40%. So this whole, let's add our 100%. So you can clearly see that our efficiency is 40, which will not be accepted by any good designer or any good technologians. So what we do to this is to find a better solution to this. Though we can have our 8 volts at the end of the day, this one is not a good method of dropping the voltage. So this is where we employ what is called power electronic converters. So we have an example like a chopper. So when a chopper comes in here, it should be able based on some switch mode principles, which we will be tackling later, we will be able to drop the voltage here down to this level perfect for the load to consume without losses of this nature. So the next videos we are going to tackle things like this. We are going to be concentrating on how we can employ power electronic switches or power electronic components to be able to achieve a very good synthesized output of electrical energy. So that is it. Thank you.